So, in the process of red cell maturation, a cell undergoes a series of differentiation. So the following stage of development or occur within the bone marrow. So this stem cell, we have this mother cell, we call it stem cell, which is the myeloid cell, the one which can go and I mean a process or stages of differentiation to give a lot of different types of blood cell. So we have the process itself equal to the hematopoietic system or the hematopoiesis. So the hematopoiesis, the process of formation of these blood cells. So we have the mother cell, stem cell, which we call the pluripotent hematopoietic stem cell, is cell which are capable of giving rise to all blood cells type. We have blood cells type, we have erythrocytes, red blood cell, we have white blood cell, we call it leukocytes, we have the platelet, these are blood cell. So we have all these different type of blood cell. So all they do arise from the pluripotent hematopoietic stem cell. So after division of this pluripotent hematopoietic stem cell, and then later on we get these all blood cell types. So the first readily identifiable cell is the erythroid series. Erythroid cells is where now there is a production of erythrocyte. That's why I called erythroid cells. Is the pro-erythroblast. This pro-erythroblast is the immature erythrocyte, the immature red blood cell. We call it pro-erythroblast. Once you say blast, this is immature cell, and cyte or erythrocyte, this is the mature red blood cell. Erythroblast, immature red blood cell. So a large cell within a large euchromatic nucleus and moderately basophilic cytoplasm. So they have a moderate basophilic cytoplasm. It is also responsible to erythropoietin. Erythropoietin, this is the hormone which is produced in the kidney. What is its function? It regulates or it accelerates the erythropoiesis process. So the pro-erythroblast contains small amount of ferritin and bears some of the proinspectrin on its plasma membrane. So this pro-erythroblast contains a small amount of ferritin. This ferritin is ionic in form. This is the iron which usually they do carry this blood. Kitu ambacho kinasafirisha blood inabind kwenye damu ni ferritin. So this is pro-erythroblast. Why it contains a small amount of ferritin? Because the pro-erythroblast hatuhitaji, we don't need the pro-erythroblast. We need the erythrocyte which is immatured. So this pro-erythroblast, this is produced before 7 days. That's why they have a small amount of ferritin of which cannot be transferred throughout the body. In the body we need the mature one. So also they bear some of the proinspectrin which is on its plasma membrane, which are responsible for the color of the blood. So the pro-erythroblast proliferates to produce small basophilic erythroblast rich in ribosome, in which hemoglobin RNA synthesis begins. So in the pro-erythroblast later on they proliferate, zinaanza kuzalishwa kwa wingi, zina produce a lot of small basophilic erythroblast. This basophilic erythroblast is where the hemoglobin RNA synthesis begins, inaanzia katika stage hiyo. So the cytoplasm becomes partially and then uniformly eosinophilic. The prochromatic erythroblast and orthochromatic erythroblast respectively. So we called in the cell we need to have cytoplasm. So cytoplasm in the red blood cell, it started at that stage, but it begins partially and then uniformly. It begins partially and then cytoplasm, which is uniformly. What we say, this is eosinophilic. We call it the polychromatic erythroblast, where there is the basophilic, cytoplasm, which is partially, and also uniformly uniformly cytoplasm, which is eosinophilic. Now we call it the orthochromatic erythroblast. So the nucleus now becomes intensively pinotic and is finally extruded from the cell. So initially now the nucleus is formed, which is pinotic, and finally it could be extruded from the cell. That's why we said the RBC, the red blood cell, it have the cytoplasm, but it doesn't contain the nucleus. So at the end of this formation of RBC, the nucleus now is extruded. That's why we said the RBC cannot synthesize protein, it lacks nucleus. So the nucleus at the end it's extruded and leaving a nucleate reticulocyte. A nucleate reticulocyte is the cell which lack nucleus, which enters a sinusoid. This sinusoid, these are the cells which are found in the bone marrow together with the liver. So its reticular staining pattern visible using special stain results from the residual. So the cytoplasm results from the residual cytoplasmic RNA, which is lost within 24 hours of entering the peripheral blood circulation. So this reticulocyte, this is a number of cells which are found in the peripheral blood and are therefore a good indicator of the rate of red cell production. If you need now to know this person or this person with anemia, there is a good production of red blood cell, we do reticulocyte count. Once now you find the reticulocyte count is high, you can see now there is a lot of RBC production. Once you find the reticulocyte count is low, now you can see now this person is having anemia because there is a problem in RBC formation. You need to know the cause of anemia. Why this now people is having anemia? Maybe there is upper GI bleeding, or now the person is bleeding more. And also if kwenye kiwanda cha kutengenezea damu kuna shida, unatakiwa kuorder reticulocyte count. Ziko chini, it means the number of reticulocytes zikiwa iko chini, now this inakupa clue kwamba there is a problem in bone marrow, maybe there is bone marrow failure. So the whole process of erythropoiesis takes place 5 to 9 days, but we saw almost 5-7 days is where the RBC now mature. After this stage, the cell is erased from the bone marrow and ultimately become an erythrocyte or matures red blood cell circulating in the peripheral, circulating in the peripheral blood cell. So from there now, circulating the peripheral blood. So this is the illustration of the previous notes. We said in the early fetal life, mimba tu inavyotungwa kabla hata ya miezi mitatu, kuanzia wiki ya kwanza, siku ya kwanza mimba imetungwa, siku ya pili, mwezi mmoja mpaka mwezi wa pili kuelekea watatu, RBC formation inafanyika kwenye yolk sac ambapo mtoto yuko imemzunguka. And then kuanzia miezi mitatu mpaka miezi minne, you can see this line, RBC inafanyika kwa kiwango kikubwa sana, RBC formation in the liver and in the spleen kwa kiwango kidogo sana. And then from miezi mitatu kuanzia minne, RBC formation inahamia kwenye bone marrow. But the RBC formation ina cease kuanzia miaka 20 kuelekea miaka 25 kwenye tibia na kwenye femur. But in the ribs, sternum, vertebrae and the cranium is where the RBC formation take place, or erythropoiesis takes place throughout the life. Also, in the genesis of blood products, we have the stem cell, the mother cell ambayo inahusika katika production ya all blood cell. We have this pluripotent stem cell of which it divides to go to the lymphoid cell stem cell, and then inaenda kwenye myeloid stem cell. Now kwenye RBC, the RBC together with the sum of the white blood cell, tunaanza kuongea na hii hapa ya chini, the myeloid stem cell. Now sisi tuna at this RBC, at this image tutarudi baadaye, tunaenda na hizi za chini hapa nyekundu. Tunaenda na za chini hapa nyekundu ambayo inatuambia ni katika production ya RBC, lakini za rangi ya kijani zenyewe ni katika production ya white blood cell. Also, so in the myeloid stem cell, katika kidude kitufe kabisa cha chini cha huku cha chini kabisa, ndio hiyo tulikuwa tunasema inaenda kutupa a basophilic erythrocyte or erythroblast, of which is immature blood cell. Within 5 to 9 days, 5 to 7 days, within 24 hours, and then within 5 to 9 days, within 24 hours going to 4 days, inakuwa iko ina nuclear, then nuclear inapungua, and then to 9 to 5 days kwenda kwenye 9 days or within 7 days nucleus inapotea, ndio unakuta mature erythrocyte haina nucleus, it has only cytoplasm. Also here in the normal production of RBC, we have normal RBC production and abnormal RBC production. But here in the physiology, you are going to see only the normal RBC production. And in the in the pathology, you will go through hematology where you can see the abnormal RBC production. In the genesis of erythrocyte, in genesis of formation of RBC, we studied the pro-erythroblast. This is the immature erythrocyte, and then in pro-erythroblast, it went a number of division kutengeneza a basophilic erythroblast. The basophilic erythroblast ziko za aina mbili. One inatupa polychromatophilic erythroblast, umeona ina nucleus nyingi, and then the orthochromatic erythroblast, of which also it have a nucleus which is tumesema ni ndogo, and then reticulocyte, the nucleus inaanza kupotea, that's why ikatupa ilikuwa ni nini, pinotic nucleus, of which inaanza kupotea, and therefore tunaipata erythrocyte ambayo haina nucleus kabisa. And then the chromatophilic ndo inayotupa color, the chromatin ndo inayotupa color ya red blood cell au ya damu. Ukikuta the chromatin now is low, it means huyo mtu iron ziko chache. You can see katika mchoro wa katikati, hivi vidude vya katikati, kuna microcytic hypochromic anemia. Unakuta cell ni ndogo ndogo sana, pia ni nyeupe, hazina damu ya kutosha. Kwa hiyo ina maana cell size ni ndogo, na unakuta huyu mtu ana upungufu wa madini ya chuma, that's why cell haiko ina kala nyekundu. And then unakuta kuna megaloblastic anemia. Megaloblastic anemia ni upungufu wa damu, lakini cell sizes zinakuwa zimevimba, na hii hapa inasababishwa, kwa mfano mtu akawa na ukosefu wa vitamin B12, akawa na ukosefu wa folic acid. And also we have sickle cell anemia. Sickle cell anemia inabadilisha shape ya color. And also we have erythroblastosis fetalis. Unakuta erythroblast ziko nyingi sana kwa fetus kwenye RBC zake, unakuta zinakuwa zimekuwa kubwa, zinavimba. We have this erythropoiesis regulation. We have hormone which regulates erythropoiesis. Erythropoiesis, we said, is the process whereby RBC now is formed. Now, if there is now enough RBC, we need to regulate this erythropoiesis. Ndo kinapokuja kitu cha positive feedback mechanism and negative feedback mechanism. For example, now there is a lot of RBC, there is enough RBC, we need now to regulate. We need this hormone to stop this erythropoiesis. Or now we need a lot of RBC. The body now senses there is no RBC. We need the RBC production. So we need this hormone which can regulate the erythropoiesis. So we have this erythropoietin hormone is a glycoprotein. This hormone is mainly produced in the kidney. So erythropoietin, that's why people with the kidney failure or kidney problem, they do suffer a lot of they do suffer from anemia, because there is a link, a good correlation from this RBC formation or blood production with this kidney. That's why mainly if someone now is having anemia, please don't forget to assess the kidney. So erythropoietin, the glycoprotein, a protein conjugate that serves as a primary regulator of red blood cell or erythrocyte. So this they do regulate the primary regulator of RBC cell. So it stimulates the bone marrow stem cell to differentiate into red blood cell and control hemoglobin synthesis and RBC concentration. So these control the hemoglobin synthesis together with the RBC concentration. So erythropoietin production is stimulated by reduced oxygen content in arterial blood in the kidney. So is stimulated if, for example, now there is a reduced oxygen content. If there is a lot, if there is not enough, if there is reduce the blood supply to the kidney, mainly also oxygen supply to the kidney could be reduced also. So the kidney could sense now there is reduced oxygen concentration to the arterial blood in the kidney. So now the kidney could sense, and after sensation and after that sense, the kidney could produce erythropoietin hormone, of which could go to the bone marrow and stimulate RBC formation and stimulate hemoglobin synthesis. So that's why hemoglobin can bind to oxygen, so oxygen could be cleared enough going to the kidney. So circulating EPO binds to receptor on the surface of erythroid progenitor cell that it turn mature into red blood cells. So we have this erythroid progenitor, ni kama cell mama ambazo baadaye zinakuwa kwenda kwenye RBC cell. In infant, erythropoietin is produced in the liver. As I said, in infant, erythropoiesis inafanyika kwenye spleen, sometimes in the liver. So erythropoietin in infant be produced in the liver, but the kidney become the primary site of erythropoiesis synthesis shortly after birth. Baada tu ya kuzaliwa, then kidney ina take place. So let's end here on the RBC production, and then we could proceed with white blood cell formation.